Okay guys, so today we're going to start working on conic sections, and I want you to see where conic sections come from. I put up there on the board, that is another example of the conic sections right there, and it's a little bit clearer on this, so if you look on Canvas you can see it a little clearer, but on our notes you can still see it. When we come in here at an angle like this, and we don't touch the top cone, the shape that's formed when we take a plane through there is called a parabola. And we've worked with parabolas before. When we come through with a plane that's horizontal, or parallel rather, parallel to the base of the cone, anywhere we go through it, we're going to get a circle. Unless we go through right there. In that case, we would just get a point. If we come through at an angle, but the angle doesn't touch the first cone, but we get through this side and this side, that intersection of the plane and that bottom cone there, that's going to give us an ellipse. We could come in this way too and form an ellipse. Okay? And if we come down perpendicular to that base or have a vertical plane, perfectly vertical, that's going to form what's called a hyperbola, like that. So we're going to be talking about all four of these. Today we're going to be talking about the most basic one, which is a circle. And I'm sure you've talked a little bit about circles before in geometry. We're going to start with this example though. Find the distance between the points shown. You can see that this point right here is at 5, 2, and this point right here is at -3, 4. To find the distance between the points, what we'd like to do is form a right triangle. So look what I'm going to do here. I'm going to drop this down, and I'm going to have this go across. Like so, to create that right triangle there. So how far is it from here to here? What's that distance? 8. What's the distance from here to here? 2. So if I want to find the distance between those 2 points, I can just use the Pythagorean theorem. I can do 8 squared plus 2 squared equals c squared. So 8 squared is 64 plus 4 is 68. Take the square root. I know 68 is 2 times 34, which is 2 times 2 times 17. So it's going to be 2 radical 17. That's going to be the distance between those 2 points. Now, if I want to find the midpoint between them, that just means the middle point. So I want the point that's in the middle of the x's and in the middle of the y's. What's in between -3 and 5? Directly in between -3 and 5? 1. Good. What's in between 4 and 2?
3.
Good. So this point right here of 1, 3, that's the midpoint. We did not need formulas to find those, did we? Now, some people are very formula dependent, which I'm not saying is a bad thing. It's just a fact. I'm going to now show you the distance formula, and you can choose whether you want to use it or whether you want to do it this way. Here's the distance formula. What we did up here was we took the square root. We took the square root of this distance. Well, how did we find that distance? What did we do to the x's? Not added. Subtracted them. If I add them, I'm going to get 2. If I subtract them, I'm going to get 8 or -8. So I subtracted the x's. Then what did I do with them? Squared them. Then I added. Where did this number come from? What was it? Subtracting the y's. And then what did I do with that? Squared it. That's where the distance formula comes from. Right? It's just the Pythagorean theorem kind of disguised. I never really use it. I always create a right triangle. And I'll show you how to do that very quickly. The midpoint is just the average of the x's and the average of the y's. That's all it is. How do you find the average of these two? What do you do to find an average?
x1 plus x2 divided by 2.
Right. That's going to tell you the x coordinate. Of course, do the same thing with the y's. Don't make it harder than it needs to be. So if I'm trying to find this distance between these 2 points, I want to think, how far is it in the x direction? How far is it from 8 to 3? How far is it from 7 to -5? 12. I'm trying to find the distance in between them. What is it? See how much easier that is than using that distance formula? I would much rather do it this way than write it out as square root of 8 minus 3 quantity squared. See? Middle, midpoint. All I have to do is find the middle of these two. You got it? And the middle of these two.
1.
Yep. Everybody see how that happened? All right. Let's go to the back now. So that really didn't have anything to do with circles. That's kind of an introduction to some things we'll need later. The standard graphing form for a circle is always x minus h quantity squared plus y minus k quantity squared equals r squared. The center is always these values, h, k. That's our center. The radius is always r, so it's going to be the square root of whatever's right here. A circle is just a set of points that is always the same distance from the center. So if I go out 5 units, every point that's 5 units away, that forms a circle. So let's look at this. It says write the equation of a circle with the given conditions. So think about it. I have to do x minus what?
X. H.
So this would be h and this would be k. So what's it going to end up being? Quantity squared plus y minus
7.
quantity squared equals 25. So that's going to be our equation right there. All right. Let's look at this one now. Here's our center. That's somebody new now. Lizzie, can you tell me what the x and y part would be?
It will be x plus 2 squared, and then y plus 6 squared equals 2.
Close. When you square this, you have to square the 2 and square the radical 7. So 2 squared is 4, and radical 7 squared is 7, so it'd be 28. Okay? All right, what about going the other direction? State the center of the radius of the circle and then graph it. So what is the center going to be? Michael, what's the center?
4 negative 3.
Grace, what's the radius? Square root of 5. Good. Now we have to graph this even. So I'm going to want to go to 4, negative 3. Now I have to go out radical 5 units in every direction. Well, I know the square root of 4 is 2, and I know the square root of 9 is 3. So the square root of 5 then has to be somewhere in between 2 and 3. So what do you think? It's closer to 2 than 3, so maybe about what? 2.3, 2.2, something like that. So I'm going to go out about a little over 2 in every direction. And create a circle. That's the way it's going to look. All right, now to the more difficult stuff. State the center and radius of the given circle. To do this, we have to rewrite this in another form. Here's what I do. I'm going to want to put the x terms together. Then I'm going to leave a blank. I want to put the y terms together. And I'm going to leave a blank. And I'm going to take the 11 over here. I have not changed anything. I've rearranged the x's, I've rearranged the y's, and I took the constant over to this side. I want to fill in these blanks with numbers that are going to complete the square. To fill in these blanks, I'm going to have to take half of this and square it. Take half of the mid coefficient and square. So what's half of this? Squared. So I'm going to add 49 here. If I add 49 to this side of the equation, I must also add 49 to this side of the equation. So I add it to both sides. All right, I'm going to have to do that for this mid coefficient. When I say mid coefficient, it's the coefficient of x, coefficient of y. What's half of it? Squared. So I'm going to add 4 here. If I add 4 to the left, I have to add 4 to the right to keep it equivalent. So now I want to factor this. Do you know how that factors?
X minus 7 squared.
Right. And how does this factor?
Y plus 2 squared.
And then 11 and 49 is 60, plus 4 is 64. So can you see how once we get it into this form, now we can find out what the center is? The center is going to be 7, negative 2, and the radius is 8. See that? That's the only way we can find the center and radius of this. So we have to get it into that correct form. All right, go ahead and start rearranging this on your own. See if you can get it in the right form. Zane?
Just give me the decimal.
No. Check your answer when you're finished. Any questions on how we got that? Everybody get it right? Raise your hand if you got it right. Okay. All right, let's look at the next one now. Example 5. Find the equation of the circle with a center of 3, negative 2 and contains the point 5, negative 6. Here's what we're looking at. Here's the center, 3, negative 2. A point on the circle is at 5, negative 6, which is right here. And I want to know the equation for this circle. Is there anything you could write? Is there anything you know so far? Nathan?
X minus 3 squared plus y plus 3 squared.
I agree. So just for writing that much, you've got 2/3 of it correct. But we still need to know this. Any ideas on how we could find this? What do you think, Zach?
If we can use the point 5, negative 6, we can draw a right triangle between the 2 points in each piece.
Sure. So he's saying just do this. How far is it from 3 to 5? How far is it from negative 6 to negative 2? So what is 2 squared plus 4 squared? What's that going to give us?
2 radical 5.
Okay, and I don't even really care about the 2 radical 5. Does anybody know why I'm not even going to bother going to the 2 radical 5? Nathan?
Get the square for the equation.
Right. This has to be r squared anyway, right? So there's no sense even going to the 2 radical 5. Let's just stop right there. We got it. Okay. Somebody in the last class thought of a great way to do this, and it was completely different. Can you think of any other way to do this once we get to this point? She found a way to find r squared without doing this at all. She didn't even look over at that. Was he?
Did you plug the x value in?
Yeah, it's a great idea. I've never seen people really do it that way, but it would totally work. Because if we just plug in x is 5, and we plug in y is -6, that's 2 squared, and that's going to be -4 squared. See how it's going to be the same answer? So that's pretty cool, too, that she thought of that on her own. So both ways will work. All right, good job, guys. I gave you the worksheet. That's your homework. That's not due until Friday, though. It will not be checked tomorrow. It's not due till Friday.